All right, good afternoon, everyone. So today we are going to talk about quantifiers, and this is another way that mathematicians have kind of reduced language and words in our writing. So let's take a look at what exactly we do for quantifying. So this is section 7.05, quantifiers. So a quantifier, by definition here, so we say, suppose x is a variable and p is a predicate. So we're going to have three quantifiers to start. So for each of these, we'll have the variable x, and then p is some predicate. So just refresh on what predicate means. The truthhood of predicates rely on a variable. So the first quantifier that we're going to have is for all. So our first quantifier is going to look like a upside down V, or a regular V with a line through it, and that essentially means for all. And so then we put x and p here because I should be clear here, this is a capital P since this is a predicate. So we would say the symbol xp, and that literally translates to for all x p. So essentially, predicate p is true for every value of x. Our next quantifier is there exists, and that is a backwards e. And then again, we denote that with our x and our p. So this says there exists an x such that p, whatever that p may be. So essentially what this means is predicate p is true for at least one value of x. So there exists an x, so it doesn't have to be just one, it has to be at least one. If we want to narrow it down to exactly one, then we use a backwards e with an exclamation point. So that is there exists exactly one. So with our x and our p, so this would translate to there exists a unique x such that p occurs. So predicate p is true for exactly one value of x. So these are the three quantifiers that we're going to focus on for today, and then we'll take a look at their negation as well. So let's go ahead and look at some examples here. So for our first example, let's say variable x represents any voter, 2020 election. And then the predicate P is the sentence X will vote for Bernie. As most of you know, I usually use my college notes for this class, and funny enough, this was the example when I took this in college in 2016 when Bernie Sanders was also running for president. So this worked then and it works now. So if I want to say, if I have my for all XP, this would translate to all voters will vote for Bernie. Then if I have there exists XP, that translates to at least one voter will vote for Bernie. And then lastly, if I have my unique there exists, we would say exactly one voter will vote for Bernie. So as you can see, if I were to just define my variable and my predicate ahead of time, I can just write these symbols, and I get this whole sentence that means these words. So as you can see, this definitely saves a lot of space, a lot of time, and as mathematicians, we love symbols. So this is just something that's going to get, once you get the hang of using them, it's going to be a lot easier when we get to proofs, so your proofs won't be so long and so wordy. You'll be able to do these with ease. So let's take a look at when we combine our quantifiers with multiple variables. So let's have we'll stick with the same the same quantifiers, but let's take a look at when we have multiple variables. So our second example here. So the variable x represents any North Star student. The variable y, so again, this is for when we have multiple variables. And this will be for any North Star class. And then we'll let the predicate P represent the sentence student X will pass class Y. So if I want to use these two variables here, I can use multiple quantifiers. So let's say I have for all x, there exists y such that p. So this would translate to every student's has at least one class in which they'll pass. If I were to do this one, so there exists X, there exists a unique Y, such that P, we would have at least one student has exactly one class in which they'll pass. And then we could also flip around the variables. So I could do for all y, there exists an x such that p. So this would mean all classes have at least one student who will pass. So we can flip around the order of our variables, and it'll make a different sentence that kind of means something different. So if we compare the first one here to the second one here, they're kind of saying something different. So every student, it's owning the student has at least one class in which they'll pass. But the last statement here is saying all classes have at least one student who will pass. So it's not necessarily saying the same thing if we use sort of the different ordering of the variables here. All right, so now let's jump into negating these statements.